So in this video, we are dealing with two more cyclic quadrilateral theorems, circle theorems. So we are saying that for the first one, if the opposite angles of a quadrilateral are supplementary, then the quadrilateral is cyclic. So it's saying here that XA and YB are the altitudes of XYZ, of triangle XYZ. Prove that AZBP is a cyclic quadrilateral. So we're trying to prove that this one here, AZBP, is cyclic. Now, our altitudes, this just means the perpendicular height. So XA is the perpendicular height of one particular triangle, and YB is the perpendicular height of another one. But we're looking at this one here. Now, for this particular case, we know that angle YBZ and this is given as it is an altitude, given that YB is an altitude, and we also know that angle XAZ equals to 90 degrees, and this is given also because our XA is an altitude and XA is perpendicular to YZ. Now, what that means, because these two are 90 degrees, they add up to 180 degrees. Now, the angle sum of a quadrilateral is 360 degrees. Therefore, we don't know what the other two angles are, but we know that they add up to 180 degrees. So we know that PBZ plus angle PAZ equal 180 degrees. Now, since those opposite angles in a quadrilateral add up to 180, we can say that the quadrilateral AZBP is cyclic because the opposite angles are supplementary. And the other two, goes without saying, this one and this one, are supplementary also because they add up to 180 degrees. Okay, now looking at one more. It's saying that if a side of a quadrilateral subtends equal angles at the other two vertices, then the quadrilateral is cyclic. So we're saying that a side of a quadrilateral subtends equal angles. So what we're going to do here, just to help you kind of visualize this, I'm going to kind of roughly draw a circle here. It's not going to be perfect, but just to help you kind of visualize what we're actually doing here, because it is hard to see it. Obviously, this isn't to scale, but we're going to roughly sort of draw up a circle here. Okay, now for this, we're told that angle XBY equals to 90 degrees. And this is given because we're told here, once again, XA and YB are altitudes of the triangle. So this is given because it is an altitude. And angle XAY equals to 90 degrees. And that's given as well. Okay, now, because those are 90 degrees and it's perpendicular, we can say that angle XBY, this one, as well as angle XAY, this one, are also 90 degrees because they're angles on a straight line. That one and the one next to it have to add up to 180 degrees. So we can say, therefore, XBY equals to angle XAY, which equals to 90 degrees. You can say angles on a straight line. Okay, now, with that in mind, this one and this one equal the same thing. They're equal. And you can see that they lie on the same arc XY. So, since they're on the same arc, and we have this angle with this relationship between the two angles, that the angles at the circumference are standing on the same arc and are equal. Because they are equal, this thing must be a circle. This shape must be a circle. And since these vertices, X, B, A, Y, are points on the circumference, then it must be a cyclic quadrilateral. So we can say, because of this, we can say, therefore, XBAY is cyclic. Because our XY subtends angles, equal angles standing on the circumference. Circumference standing on the same arc XY are equal.